This is question number 12 on our practice end of course assessment with released questions from 2018. So question 12 states points A, B, and C lie on a circle with center Q, the area of sector AQB. So I just drew this picture out already. Center here is Q, and then we have A, B, and C along the circle. And you can see I've shaded the sector AQB, and I just eyeballed it to make it look twice as big as sector BQC as stated in this question. It says the length of arc AB is 28 centimeters. So there's a property that needs to come to mind, and that is that the areas of the sectors are proportionate to the length of the sectors that they intersect. So we know that this length is going to be, since it is twice the area, that the length it would also be twice as long as x. So we can logically just say 28 divided by 2 is x, or x equals 14. So 14 centimeters would be the length of arc BC. Question 13 asks, which term is defined as two intersecting lines that form four right angles in a plane? Basic definition question. The answer to that would be perpendicular lines. Question 14. A cone and a sphere of the same volume. The height of a cone is 96 units. What would be the values of the radius of the cone and the sphere? So this would be two separate things. Round your answer to the nearest hundredth as needed. So in this question, I just kind of rewrote the key information on my paper. So the volume of the cone and the volume of the sphere are equal. So the height of the cone is 96. We have to figure out the radius of each, the cone and the sphere. So I turned to my little formula sheet here, and I noticed that I have the volumes for each of these listed. So I'm going to go ahead and substitute those in. So we have the volume of the cone is 1/3 pi times the radius. I'm going to continue to denote cone since that's going to be different. It doesn't state that their radii are the same. The radius of the cone and times the radius of the cone squared times the height, which I know is 96. And then it's going to be equal to the formula for the volume of the sphere, radius of the sphere, and that is cubed. So there's a variety of ways to go about this. One way that you could do that is to go ahead and simplify things a little bit. We could, if these were equal, let's go ahead and kind of get rid of this fraction here by multiplying by the reciprocal. Sorry, I just did the same thing. 4/3, so the reciprocal is 3/4. I need to multiply both sides by the same thing, which cancels out the 3 and the 3, so now I'm left with 1/4. And then these cancel out. I could also notice that if I divide both sides by pi, that kind of simplifies things a little bit as well. Those go away. Now I have 1/4 times the radius of the cone squared times 96. I'm going to multiply those out in a second, equals the radius of the sphere cubed. Now 96, we'll do 1/4 of 96, or 96 divided by 4 is 24, times the radius of the cone squared. I'm going to go ahead and now subtract this radius from both sides. That's going to set it equal to 0. So basically what I need to do here is figure out 24 times some number squared minus some number cubed is equal to 0. Well, one thing that comes to mind is if I made the radius of the cone 24, because then I know 24 times 24 squared would be the same thing as 24 cubed. So if I go ahead and plug in 24 here, it's kind of like, you can think about it as a guess and check. And then we do that minus 24 cubed, we get 0. So if I went back and plugged everything in, I would find out that their volumes would then, back to the beginning, be equal. So I'm going to say the radius of the cone is 24 and the radius of the sphere is 24. There are multiple ways to do this problem. You could get different answers, but this is one of them.